situation now with 1,000 requests per second, and we tested failing 1 or 2 servers at a time, and we didn't see any others fail. Then we actually tested failing half the servers out. In all of these situations, the TCP sessions to servers that were not impacted were never interrupted, which was the desired goal of consistent ECMP. The other challenge we ran into along the lines of consistent ECMP is that ultimately every router based on vendor magic, which will generally end up being a combination of when the BGP sessions were brought up, when routes were learned, router IDs and neighbor IDs, they will build a different hash table. So we had to accept the fact that if we have 2 routers facing a data center and requests being distributed relatively evenly, although we have per flow distribution based on a hash table for all modern routers, we're going to end up in a position where if a link in the backbone flaps or a transit link flaps, we can see traffic remapping between different routers. And what this is going to mean is that we're going to be sending it to a different server. So we'll do a TCP reset. We actually conducted some measurements on this before implementing and found that we were generally moving TCP sessions between routers less than once per week. And for our stack at least, our application teams advised us that as long as we didn't move more than once every 5 minutes or so, we were probably okay. The next challenge we ran into was that the ICMP packet too large alerts, I've already talked about this. The ICMP packet too large alerts do not get hashed correctly. So we started fixing this by lowering the MSS to 1360. And this wasn't just for this reason, but also because we can't actually rely on ICMP packets making their way across the internet successfully at all times. We found that 1360 solved the MTU problems for 99.99% of clients affected. In fact, it was probably a little bit higher than this, but then we solved the remainder of them with TCP MTU discovery, which is a mechanism for when we send out a TCP response and we don't get a response, to continue sending that response again and again until we actually find an MTU where we can get a reply back. If you're not doing this, you would need to be thinking about making sure there's room for the 24-byte GRE tunnel overhead. But if you're dropping the MTU anyway to fix client-side problems, it's probably not an issue. If this was an issue, you'd either need to run jumbo frames in your data center or drop your MTU down a little bit, or enable fragmentation in your data center. We also started to think about what would happen if a server was flapping for some reason. While the load balancers we had from vendors put us in a position where we could set a hold down timer so that if a server was flapping, we didn't bring it back into the rotation for a wee while. On a router, we don't necessarily have that functionality to be that granular. We actually solved this by enabling route damping, which I'm sure most of you think should have gone with the Dodo, but has actually been really effective in this scenario. So we've been very conservative with how we've implemented this, and that we require quite a few flaps before we kick this in, just because the last thing we wanted was a rolling restart to cause all of the VIP routes we're advertising from servers to be withdrawn and take down the site. But it's protected us in a couple of scenarios where a service has been thrashing on a server and causing clients to move back and forth regularly. Finally, we had a challenge of draining sites and draining hosts. So for draining hosts, it was actually really easy. Rather than pushing a config change to a load balancer, we now just withdraw routes from the server, which can be done by our SRE teams rather than involving NetEng, which is great. And then in terms of draining a site, we already had methodology to stop accepting BGP routes from our load balancers on the site. So this wasn't difficult to implement in this method as well. It's the same functionality. So the biggest thing we thought about in doing this was about vendor lock-in. The last thing we wanted to do was work with one vendor, develop a bunch of really cool technology that allows us to be far more flexible in our methodology of health checking and advertising new services, but then be locked into that vendor for fear of no other vendor supporting this. So we actually reached out to Juniper, Alcatel, and Cisco, and found that both Juniper and Alcatel support this function, all the functionality described here right now. So if you have their routers, you're fine. And Cisco plan to implement by the end of the year. So we were actually really encouraged at the amount of support all the vendors gave us, particularly Juniper in this case, in doing this. And it's been really great for our service, being able to enable ourselves to scale without having to constantly ship another ATN to site. And that's all I have, but I imagine you guys have a few questions.